Let's begin. Today's October 2nd, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 4, 7, 12, 17, and 21. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. Criteria card A looks at our middle digit, the square digit, and compares it to the number 4. So should the value of square be less than 4? Should it be equal to 4? Or should the value of square be greater than 4? Criteria card B looks at our last digit, the circle digit, and will let us know whether it's an even digit or an odd digit. Criteria card C looks at our first and last digits, triangle and circle, and compares them. Should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will take a look at our 3-digit solution and will let us know how many of those digits are even. Are there no evens? Is there a single even? Perhaps 2? Maybe even all 3 are even. And finally, criteria card E again takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, it can tell us whether there's a pair of digits, as in the example 131, or alternatively, there are no pairs, but there are 2 cases. One where all the digits are different, as in the example 134, or all the digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that one unique code that abides by all of the 5 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to test is I want to know a little bit about that last digit, the circle digit. So let's go ahead and test criteria card B. Okay, so the Turing machine responds that it agrees with my choice. I did pick an even 4 for circle. So it confirms, yes, that the last digit should be even. So let's go ahead and type that up in our notes for section B. And that is that circle is an even digit. And since it is even, that means we can cross out all of the odds for circle. So let's cross out 1, 3, and 5. The next thing I think I'd like to test is criteria card E. Okay, so the Turing machine does not approve of my proposal. Notice that 314 are all different. So that falls under the no pairs scenario, but we can disqualify that since the Turing machine does not agree with it. So in fact, there should be a pair. So let's go ahead and type that up in our notes for section E. And we'll say that the solution has a pair. Okay, well, we obviously already have one even. Kind of curious if it's a pair of evens. And we do have criteria card D. Let's see, so we know there can't be 0 even since we already have 1. Could we have all of them be even? That's possible. I do have 1 even. Well, let's go ahead and test. Yeah, criteria card D. Let's see. Okay, so the Turing machine does not approve of my choice of only having 1 even. So again, it can't be 0 because we already have 1. It didn't like the fact that I only had 1 even. So really it comes down to having either 2 or even 3 even digits. So let's go ahead and type that up in section D. And we'll say that the solution solution has 2 or 3 evens. Okay. Yeah, I don't think there's anything. Obviously, if there's 3 evens, one of them is going to be paired up. And in the other case, I guess by default, we're going to have 2 evens regardless, and they're going to be paired up. So the question is that third digit going to be even or odd? All right. Well, we did complete our 3 Turing tests for round 1. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our middle digit to 4, and we also did not test criteria card C, comparing our first and last digits. So it is, interesting just to note that criteria card C does have that equal. So just curious if that first and last digits are even. And it is interesting. So, I kind of do like that, only because we also have this other card, square, that'll let us know what it is. And obviously, the only 2 definitive choices are either 4 or 5, since we do have square that could be equal to 4. And the only possibility for square to be larger than 4 would be the number 5. So both of those would allow us to pinpoint what square might be. Now, what about, so I kind of go back to criteria card C, and now that I think about it, if they are equal, and obviously they'd be even, how would you choose between the values? The only thing that comes to mind is that maybe there could be 3 evens, and that would force a square to be 4, and then triangle and circle to be 2, since we only have a pair and not, a triple digit or a triple number. That's the only thing that comes to mind. Obviously, there could be, plenty of other possibilities. Just trying to think of, if triangle and circle are not equal, obviously that would help us to maybe sort through which pair of digits it could be. But I think I'm just going to go with what I just suggested. I'm going to go with 2, 4, 2 and see where that takes us. 2, 4, 2. All right. Well, it was a bit of a risk to choose the square digit to be 4. But first, let me go ahead and test criteria card C and see if the first and last digits are equal. Okay, so they're not. Okay, so let's see, how do we type that up? We're going to say that triangle is either less than or greater than circle. So let's go ahead and do that. So triangle is either less than or greater than circle. So we know that they're not equal. So what does that tell us then? If triangle and circle are not the equal ones, well, that means that square is going to be paired up. We just don't know if it's going to be with triangle or circle. So we're looking at, either, say, for example, 2, 2, 4, or maybe 4, 4, 2, or triangle's the one that's now paired up, and square and circle are. So the most likely candidate, I would think, let's see, Again, I'm thinking that they are going to be all even, just so that it forces the issue. And whatever square is, that's what circle might be. So let me go ahead. I'm hoping that square will be 4, but I'm not sure. So let's go ahead and test criteria card A. It is not 4. Okay, wow. Well, now we're really, let's see. So we have, again, square is either less than 4 or greater than, let me rewrite it as less than or greater than 4. Okay, well, so that just means that we can cross out the 4 for square since it's not 4. Okay, and I think I may just have to test criteria card D again, because I believe that's the one that still has not been kind of confirmed. So I don't think we're going to have a pair of 4s, because we already know that triangle and circle are not equal. So I believe 4 is going to be the one that's not paired up, it would seem. So we do have, or we are going to have a pair of 2s. Yeah, so let's go ahead and test D again, just to confirm that we have all evens. Okay, wow, so no, we only have a pair, 2 evens. So it didn't like the fact that I had 1 in round 1, and it didn't like the fact that I have 3 in round 2. So yeah, so that points to only having a pair of evens. Wow. Okay, so let me go ahead and update the notes here. So we have only 2 even. So at this point, again, as I stated earlier, I don't think we're going to have a pair of 4s, because we already established that triangle. Oh, did I not copy the circle for my notes in section C? I might have forgotten that. Okay, there we go. So we can't have it since we already know that they can't be equal. So let's see, how many possible solutions have pairs of 2s? So we know that triangle and circle can't be equal. So it's going to be something like 2, 2, and then, oh, because we only have 2 evens, that means that square and circle are going to be even. Oh, look at that. Is that right? Is that right? Yeah. So triangle cannot be even. Triangle has to be the odd. So that means we do have 2, 2. Okay, wow, maybe we don't have to go to the 3rd round. So let's see. So what I'm thinking is that triangle has to be odd. So it's either going to be 1, 2, 2, 3, 2, 2, and 5, 2, 2. And in the last 2, we see that triangle is larger than circle. So I'm thinking that those 2 are going to be ambiguous solutions, meaning I can't tell the difference between them. Yeah. So I think we might be able to deduce that triangle has to be smaller than circle. So let's go ahead and see. So let me just type up what I believe to be the answer of 122. And actually, we may have more to deduce. So let's see. So we'd be deducing that square is less than 4, which would be 2. And then we'd, let's see, yes, circle's even. I believe it to be the paired. So it's another 2. And again, we'd be deducing that triangle has to be smaller than circle. There are 2 evens, and there's a pair. Yeah, we can't have 3 evens. So yeah, triangle is not paired up with circle, but circle's even. You do have 2 evens. You got a pair. That forces square to be the other even. And the only even left in square is 2, forcing circle to be 2. And then triangle 3 and 5 would be ambiguous. They're both greater than the 2. So we need to pick 1, 2, 2. Okay, it looks like that may be the solution. So let's go verify of 1, 2, 2. This is an interesting puzzle. So 1, 2, 2. Fantastic, that was. Okay, well, how do we do with a Turing machine? This will be interesting because we did have 5 criteria cards and we did 6 tests. We had to do D twice. And in the first round we did B, D, E. And in the second round we did the remaining and tested D twice, a second time. So let's go type that up. So we got B, D, E in the first round. So B was correct, D and E were both incorrect. Second round, all of them were incorrect, A, C, and then D a second time. Wow, okay, so we still beat the Turing machine by 1 question. Yeah, this was, I don't know, I find it very interesting. Like I've said in previous puzzles, this board game Turing machine really does, it does a great job of illuminating kind of how special all of these numbers are. And it just does it in such a fantastic way. Well, what do you think? How did you solve? I'd be very interested to know what order of criteria cards you used to solve and how you did. Please add your thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.